how to get these answers as soon as we can. Well, it takes practice. So it just takes practice. All right, so starting I'm going to go down the list and I'm going to ask each of you to try these questions. Number 1, Adrian Anguiano. What am I doing here? Read this question. These first ones are going to be solving limits, by the way. So, Adrian, what's the answer? How do I do this? Adrian, you there? What am I doing, Adrian? No, look at the question. Read it. Explain it to us. What does this question want us to do? That is exactly what you do. Yes, it's a limit, right? We're finding the limit. And so when we find a limit, plug it in, right? So what's the answer? Which is, there you go. Answer number 1. Thank you, Adrian. See how quickly those could be done. All of these questions, by the way, that I'm listing you here, were taken directly from previous AP tests. All right. Jesus Ayala, number 2. What do I do? Ayala. Are you there? Is he here? You're here. What am I doing? Minus 1,000 points for Jesus Ayala. Leaving me hanging here. All right, I'll have to come back to you. Stephanie Fuentes. Let's try you. What do I do? I do. What's the answer? This is nice and easy because you're plugging in a 1, right? You don't really need to worry about the cube or the squared or anything like that, right? It's going to be 5 minus 6 plus 2 minus 1. So it's going to be, that's negative. This here is negative 1. Minus 1 is negative 1. Plus 2. What's the answer then? It'd be 0. There you go. Right? So, again, quickly being able to do these problems, right? Recognizing the math they have you do is not challenging. It's just there's lots of these little tricks that they want you to do, lots of these things that they expect from you, all right? All right. Thank you, Stephanie. Priority so number 3. I do. So what's the answer here? So notice how they give you really nice numbers these times, right? We're plugging in a 4. This thing had a square root, but it was a 4 square root, right? So it's like really nice numbers. 8 divided by 4 is really nice, right? So like they give you nice numbers. Square root of 4. Square root of 4. That's 2. And this here, it's the only part that's like maybe a little bit math. 3 times. And that's the only thing that maybe you need a calculator for, right? That'd be 48. This is a plus 2. Close. 40. Right? Be very careful, the simple math, right? And you can think of it like this, right? You're minusing 4, but you're adding 2, so really these two is really minus 2. Right? You kind of combine those together into a minus 2, so 48 minus 2, 46. Very good. Very good. Thank you, Pariso. Michael. Mr. Jones. Number 4. What do I do? Should we try plugging in 7? What happens if we plug in a 7? Is it? So we get 7 squared minus 6 times 7 minus 7, right? 6 times 7. So that's going to be 49 minus 42 minus 7. So that's going to be 0. And this bottom part's definitely 7 squared minus 49. So that's 0 on the bottom. So that's indeterminate, right? So this is where we realize we're going to have to do some factoring. And there's a clue. I mean, there's kind of a, we can kind of tell because they have this factorable pieces on the top and the bottom. Yes, Jessica. Yeah, exactly right. This is a factorable thing, and they don't give you this. What's the word? They don't give you this lightly. You know what I mean? They give you these things with the indicator that, you know what, you're probably going to have to factor. They give you those things because you will have to factor. So it's like a clue. And knowing these clues, knowing how these test makers think, really gets you a lot of ways here. So we're gonna have to factor. When you see this, pretty much immediately you should go, oh, I know I'm gonna have to factor. I'm gonna have to factor this. So what does this factor into, Michael? Any help here? What parentheses up here is this gonna be? What parentheses down here? How do I factor this? What's your question, Michael? So what do I factor here? Your audio not working? Remember factoring, folks. Oh, internet's going bad. All right. So remember factoring. Thank you, Maria. Yes, right? 7, I got a 7 times a 1, and I need to add to 6, so I got to make a negative 7 plus a positive 1 to make negative 6. So x minus 7, x plus 1. Bottom, this is a perfect square, so you should know this automatically, x minus 7, x plus 7. You should know your perfect squares automatically, right? 49 is a perfect square, 7 times 7, break it up like that. And so now we see this minus 7 and the minus 7 can cancel. And this is how we did this factoring, right? How we did this solving. So we're left with x plus 1 over x plus 7. And now you plug in the 7, you get 7 plus 1 over 7 plus 7. That's going to be 8 over 14, which is going to be 4 over 7. So some questions, especially ones that have quadratics, you're going to need to factor those pieces, and then do some canceling. Once you've done the canceling, you plug in again, and you solve this. These multiple choice questions are not going to be too concerning about like using the right limit format. That's only for like where you have to write the word limit every time. That's only worry about that for the free response questions. Multiple choice you want to do as quickly as you can, as fast as you can. Use whatever strategies you can. Write it however makes sense to you. Work it out in your head. If you do it all in your head, that's fine, but get it done quickly. All right. Let's go with Manual, number 5. Emmanuel, number 5. What do I do for number 5? What special thing is happening here? Walk us through it. What do you notice? Read the question and tell us what you see. Okay. Go on. All right. Wonderful. Can hear you. Great. So tell us what you see. Okay, so what immediate clue, what's the first thing that you notice that's like different about this question? Yes, right? That's something special. This means something special, right? It means we have a particular strategy for finding infinity limits. Now, do we remember what that strategy was? What was the? I'll give you a hint. What was the important? What were the important numbers when we took the limit to infinity? What things were the important parts? Don't remember? Anyone want to help me out? What was the important thing? When we did limits to infinity, only a certain section, only a certain part of the equation was important. The signs. The signs are important. Yeah, if it was positive or negative infinity, that would be important. But I'm more talking about, where'd my mouse go? I'm more talking about the things in here. The things in here. What things in there are the important parts? Jennifer got it. The biggest exponents, right? When we deal with infinity, the only things that matter are the biggest exponents. All these other pieces, we don't care about that, I don't care about that, I don't care about that. That was the trick with infinity. Only the biggest exponents mattered. Maria says cancel the weak variables. Yes. Cull the weak and keep the strong. Exactly, right? So the smaller ones go away. So now, Emmanuel, we have an x squared over an x cubed. Or basically we have infinity squared over infinity cubed. You can imagine plugging in the infinity. And do you remember what happens when this situation occurs? What we can do here? Emmanuel? No? Well, I mean, one thing we can do is, if we have the same on the top and bottom, yeah, just because we can cancel, right? I have 2 infinities up here can cancel. So I got a 1 on the top, 1 infinity down here cancels. I have 1 leftover infinity on the bottom, meaning my infinity is bigger on the denominator. And what was the answer when we divided by infinity? If you have an infinity on the denominator, it gave us one of the particular answers. Do you remember what that is? If we divide by infinity, what number does that get us? Think of a number 1 divided by 10 million. Is that going to be a big number or a small number? It's going to be a number that exists. If you take 1 divided by 1,000, 1 divided by 1,000,000, 1 divided by 1,000,000,000, is that going to be a big number or a small number? Right? Take 1 and divide it into 1,000,000,000 tiny pieces. Right? It's going to get you a small number when you divide by. So the answer, when we divide by infinity, it becomes the smallest number, which is 0. And that was the trick with infinities. One of our tricks to remember is that when we divide by infinity, we get 0. So when our limits to infinity, we look at the biggest exponents. If the denominator is the biggest, the answer is 0. And that's why. All right? Is that helpful, Emmanuel? Something to remember. Keep these notes, everybody. Limits to infinity get you 0. Ayala, you're back. I'm glad to have you with us. Glad you survived. Number 6. Same thing, same question to you. What is the answer for this one? Walk us through this. Did you get locked out again? Ayala, are you there? Cancel small exponents, yes. So what do I have left? I have, oops, not the 5. I need that 5. The 9 and the 2. So I have basically I have infinity to the 7th power over infinity to the 5th power. So what's the answer of that going to be? That's a 5 down below, not an 8. 5th power. So this time, my infinity is bigger on top. So what's that gonna mean? What's my final answer there? Any ideas, Ayala? Checking his notes, figuring it out. We have infinity on the top. Jessica, yes. That's a 5 on the bottom here. That's a 5. I don't know. My pens are having a hard time. 5 on the bottom. Yes, Ayala, it'll be infinity over 1, which is what? I mean, it's infinity divided by 1, which is really, I mean, the answer is just infinity here. That's what we're left with. When you have infinity on the top of a number, right? The answer is just infinity. So when you have the infinity on the bottom, we get a 0. When you have infinity on the top, you get infinity. So if your numbers, right? If your numbers are bigger on one side than the other, then we have these two special situations. Infinity on the bottom, you get a 0. Infinity on the top, you get infinity. Well done, Ayala, well done. Maria, number 7. Walk us through this one. Yes, about which? Yeah. Yeah, well, yeah, and that's true all the time, right? If I said 5 times 3 divided by 5, right, my 5's cancel. It becomes a 3 over 1. So just like how when we divide numbers, it becomes a 1, we divide infinities and like infinity divided by infinity. Also, you can think of it like becoming a 1. Yeah, no problem, no problem. All right, Maria, number 7. Walk us through this one. So first strategy, cancel out the weak. Cancel, 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 cancel. So I have 7 infinity to the 4th power. Oh, sorry, negative infinity. Divided by 5 times negative infinity to the 4th power. What's this going to be, Maria? Okay, so all 4 of these infinities cancel with all 4 of these infinities, so what do I have left? There you go. Very good. So this is one of those situations where when we're taking a limit of infinity, the exponents match. And when the exponents match, the only thing that matters after that, right, we have basically the same exponents on top and bottom. All the infinities go away. And the only things that matter are the coefficients in front. So when your exponents match, you have the coefficients, and that becomes your infinity answer. Now the negative is important because if one was bigger or smaller, like if this was to where is this? If this was like negative infinity to the 7th power, then this answer would be negative infinity. Right? Your signs are also important here. Like Jessica said, your signs are important. But when the exponents match, they cancel entirely, and you're left with just the numbers in front. Very good. All right, let's keep going. Right, these are how quickly you need to answer these questions. 1-2 minutes for these quick, simple questions. Angel, number 8. This is a little different. Walk us through what's happening here. Read this for us. What do we see? Okay, and what are we trying to find? What does that mean? What's this little positive mean? Angel. So this positive means the direction we're doing the limit. From the right, yeah, from the right. We're taking the limit towards 2 from the right direction. Oh gosh, from the right direction. So, yeah, same directional limits. You do the same thing. You plug it in. Directional limits. You also just plug in, and then you got to deal with what happens. So if you plug it in, what do we get? Yeah. So what does that mean? Do you know what that means? No, not that it doesn't exist. It might not exist, but it means we have something like this at 2. At 2, our graph goes up to infinity, or down to negative infinity. Maybe it goes like that, or it could go, maybe it goes down up this direction and up this direction. Don't really know which one it is. And so, yes. So if I tried to find the limit as x approaches 2 without the direction here, right? Just the full version of 2, that would not exist. Because if it goes up on one side and down on the other, that's where our limit, it doesn't reach the same point, right? When you have full limits don't exist. If you're going from a certain direction, well, we can find the single side, right? We can find one side. Either this 1/2 is going to go up, or the 1/2 is going to go down, like the right direction. I mean, from the right direction, either my limit's going to go towards infinity, or it's going to go to negative infinity. So I can find an answer from the side, from one side or the other. But when I try to combine them and make one big limit, the full limit, and they're not going the same place, they go one up, one down, that's where it doesn't exist. Or if you had a piecewise function, those would also be an example of something that doesn't exist. But the sided limits, we can always find an answer for the sided limits. Okay, it's either going to go up or down. So, Angel, my question is, in this equation, 2 from the right, from this side, we're going from this side, is my graph going to go towards infinity, or is the graph going to go towards negative infinity? And how do you tell? Do you have any ideas? Angel, any ideas? Why would you say that? So yeah. It's going towards the right. So because the 2 is positive, you're saying that you think we have this graph. where when we approach 2 from the right side, we're going up, and not this graph, right? Where we approach 2, we're going down. It's because it's one of these two graphs. You see what I'm saying? It's either this graph or it's this graph. And you're saying, well, you think it's this one, not this one. You're not sure. Yeah, because it's hard. I mean, like, we don't have any information, right? We don't know which one is which. There's two ways we can do this. Two ways we can solve this. One is to graph it. Use a graphing calculator. Plug it in. Plug in the graph, and then you'll see which one it is. If it's this first one, this is going towards positive infinity. If it's the second one, this is negative infinity. So, like, one way, easy way, graph the equation. Jessica, that answers your question. How do you know which way it goes? One way is to graph. The other way, the second method you could do, is plug in close to the number. So I want 2, but I want just to the right of 2. So I'm going to plug in like 2.1, right? If I plug in 2.1, a little bit more than 2, if I plug 2.1 into this equation, if I plug 2.1 into this equation, I'm going to get negative 5 times 2.1, negative 5 times 2.1 over 3 times 2.1 minus 6. Right? This is going to be negative 10 point something on the bottom, a negative number on the top. On the bottom, it's going to be something that's more than 6 minus 6. So it's going to be a positive on the bottom. So I plug in 2.1. I find f of 2.1. Plug it in. I get a positive on the top, a negative on the top, a positive on the bottom. That means my answer is going to be negative. A negative divided by a positive is a negative number. So my answer is negative infinity. It's this one here. So with limits of infinity, like as you're getting asymptotes, you have to either graph the equation or you got to plug in a number on the side that you want. Plug in a 2.1. If we were going from the negative side, plug in a 1.9 and determine if it's positive or negative. If it's positive, you're going up to positive infinity. Doesn't matter what positive is, if it's positive or negative. You're just testing signs. Testing your signs. Test the signs. Oh goodness, test signs. Yes, the more questions, the better. Looking at these two equations, or looking at these two graphs, right? You're saying you need to look at the direction that you're approaching the two from. So this is approaching from the right, correct? So you need to, like, you're walking along this direction now. And so from the right direction, from the right, you look at the direction you're going from the right side of the equation. Does that make sense? Does it answer your question? Yeah, so you look at the direction that it's coming from, and that tells you which side of the asymptote you're on. All right, so that was a tricky one, Angel. Good job, thank you for that. I got like 1 minute left, right? Oh, I got negative minutes left. Aren't we done? 25, right? That's where we're at. Oh, such a good time too. All right, everybody. We'll have to pick this up later. So your test tomorrow, I'll tell you where to go, and I'll send you the links tomorrow. Study this, send me questions, practice things on Khan Academy and IXL, and do all those things. Let me know what questions you have. Work on this practice. I will see you all tomorrow. Say goodbye in the chat. Once you say goodbye, you're free to go. Have a great day. Yeah, not a problem. I'll be here.